Hello world, it's Siraj, and I've built an app called Artificial Advisor that helps you manage your personal finances. The point of this video is to show you how I built it so that you could build something similar yourself and make money with it. So let me start off with a demo. I'll start off by typing in my username and my password. And this is just test credential information. And once I've logged in, it's going to ask me to authenticate with my bank account. Now this screen is just there for testing purposes, but once I've logged in, I can select many different bank accounts. I've integrated a service called Plaid that lets us integrate multiple different bank accounts. And I'll just pick one at random, Bank of America say, but there's a lot of different bank accounts I've integrated here. And I'll type in my test credentials. And it's going to show this beautiful credential loading screen that's going upwards. And once I've authorized, it's going to show me both my checking and my savings account balance. And once I click on checking, it's going to authenticate that information. It's going to pull all of my transactions directly from my bank account into my app. Then it's going to display the categories of purchases that I've made in the past month. And, you know, that could be food, that could be transport, whatever, and it will visualize that as a pie chart as we see here. Then, once it has all of that data, it's going to take a 1% cut of that, and that's going to be an investment. That's what we're going to do. We're going to take a 1% cut of your monthly budget. And once I've done that, I have an artificial advisor that I can talk to. I'll go ahead and say hello. Now I'm going to ask my artificial advisor, how much is my balance? Just to see if, what it is. Okay, I've got $100 in my bank account. Great. Now let me see what my budget is. What is my budget? And what it's going to do is it's going to tell me the breakdown of my monthly budget. Right now, it is allocating different amounts for different categories of purchases for me. It's allocated this itself. And then I'll say, okay, great. Well, based on this budget, can I afford some products? So for example, I'll ask, can I afford a Tesla Model S? So that would go under transport. It will pull the price of a Tesla from the Google API. It will compare that to how much I have in my budget. And it's going to say, oh, not this month. That's outside of the range of your budget of $10 in this test case. Great. Now I'll ask, how are my investments doing? How are my investments doing? And it will say, depending on what the price is, your current investments in Apple and Google have this loss and win, and the net gain is $1.28 for today. What this app has done is it has selected some category of stocks to invest in. It's used sentiment analysis on Twitter data to see which stock it has a high sentiment for the day, and then it's invested in that stock using what's called the Alpaca API. I'm going to explain all of that. But that is the demo for this video. I'm going to show you how to build this so that you can build something similar. Now is the time to build an AI startup. And if you want to continue to see these kind of educational videos on how to make money with AI, hit the red subscribe button because I'm going to keep pushing them out every single week. Now, that's what this app does. I'm going to show you how I built it, and that includes a lot of tools like Firebase, which lets us authenticate our users and gives us a database that's easily accessible in the cloud. Plaid, which allows us to integrate with many different bank accounts. AnyChart, which lets us visualize the data that we pull from Plaid. Dialogflow, which is Google's online tool, which allows us to use NLP that's been pre-trained to create an agent that can converse with our user. We'll also use Tensorflow to perform sentiment analysis on Twitter data. And then we'll use the Alpaca API to make trades in real time with zero commission, which is awesome. So I'm going to show you how I put together all of these tools to build this app in this video. Okay, so let's go ahead and get started. I have a little short presentation, 5 minutes, on what this app is about and how it's using AI, and then we'll get right to the code, all right? So important question, how is this AI? Well, it's all considered natural language processing, and here's how. First of all, the Plaid API is an incredible API, and what it does is it returns bank data once I've authenticated with whatever my bank is. And what it's going to do is it's going to return that as a JSON response, right? It's in the JSON format, which is one of the many different formats that data can be sent via the HTTP server client model. And in this case, look at this. The amount is going to be $44.87 in this example, and it's also got a category feature. Whether, what is that transaction categorized as? Is it travel? Is it gas station purchases? What is it? And the way they do this is they're using some kind of supervised model on their end. They've trained it on all of their transaction data, and of course they have a lot of it. And because of that, they're able to classify new transactions based just on what the text of that transaction was. It's going to know the likelihood of what category it's in. So they're taking care of that part of the AI process. And it's using some sort of neural network likely to make some kind of multi-class classification. Now, how else is it using AI? Well, it's using intent classification, and that's for using Dialogflow. So the idea behind intent classification is a user could say different things. They could say, what is my budget? How much money do I have allocated for this month? What is my, another word for budget? The point is that we are shifting the paradigm from what a user says to what a user means. And that is intent classification. No matter how they phrase a certain sentence, the intent for all of those phrases that I just said is going to be the same, right? Budget lookup is the intent for that. So what Dialogflow allows us to do is to classify text and put it into these intent categories. And once we have those intents, then we can give a response, whether it's a hard-coded response or whatever else. And the way they do this is to take those words, convert them into vectors, and it's very likely that they're using their own model for this called BERT. And I have a great video on this. Just search BERT Siraj on YouTube. And the other way we're using NLP is through text generation, right? Our agent is not only able to give out hard-coded responses, but we can have it give some variant of a hard-coded response. And how does it give a variant of a hard-coded response? Well, it uses what's called text generation. And the idea, to be mathematical for a second, is to, instead of just estimating the probability of Y given X, right, the probability of a label given the input data, it's to estimate the probability of X given Y. So it's the opposite. So what we're doing is instead of estimating a decision boundary, yes, no, hot dog, not hot dog, we're estimating the probability distribution of the data. And a distribution shows all the potential possibilities for what value some data could be, from 0% to 100%. And so all the variations of what some data could be is contained in that probability distribution. And so, if we want to generate new types of Pokemon based on a data set of existing Pokemon, whether we want to create some new type of response based on some existing text data set, the point is that it finds some variation that's related, but it's not the exact same from the original training data set. So one example in terms of text generation would be, let's say it's trained on a bunch of compliments. One of the compliments it's trained on is, your hair looks great today. And after training, using the distribution of all of those hair compliments, it would generate something totally different but related, like your hair is fantastic. And the word fantastic wasn't in there, but it's related. And so word2vec helps with that because it was pre-trained on a bunch of word vectors. Lastly, it's using sentiment analysis to categorize each of the tweets that we're pulling for each stock via what's called a text CNN, a text convolutional neural network. And I have a great video on how that works as well. Search text CNN Siraj. Once we have the sentiment for each of those stocks, we're going to make a trade based on what we consider to be the highest scoring sentiment stock for the day. Now, before we, get started with the coding and stuff, I just want to say that this is not enough to make a, great, amazing trade, right? This is just one data point. Sentiment analysis is one data point to add to our investment model. Now, but remember, this app isn't just doing investment. It's allocating your budget, telling you whether or not you can spend a certain amount. So investment is just a part of that. And so this is just a boilerplate prototype. We can continue to build that investment model. Instead of just adding sentiment analysis, we can add some cloud function in Firebase that uses deep reinforcement learning to make trades in real time. And there's a lot of ways we can improve that. We can add back testing. But the point of this is not just investment. Investment is one part of this. There's a lot more to this. How much can I spend? Can I afford a certain product? Letting us know whether or not we can afford something, right? We make these investment decisions ourselves with our own money, but we're not that good. At least let me speak for myself. Well, I am pretty good, but I could be better. Everybody could be better, okay? So the point is that that's how it's using AI. Now, applications of AI in finance. Last step before we get into the code. There are lots of opportunities here, right? Now is the time to start an AI startup. And that could be in credit scoring. It could be in asset management. This is just one example of startups and companies that are using AI to solve some really hard problems. Basically, anytime you can think of something that a human is doing in finance, there's a very, very high chance that an AI can do it just as well. And the problem is that AI is the new electricity, but just like electricity was invented, it had to be propagated throughout the world for it to be used. That's our jobs as engineers. We have to propagate this technology by building startups. That's how AI is going to influence society. So there's a lot of room for great AI fintech startups. Now is the time to build it. Very few people realize just how accessible this technology is to anybody anywhere and just how powerful it is. And very few people have the knowledge not just of those 2 data points, but how to build it. And so my goal for this video is to do all 3 of those. To get you excited, yes, you can build this. I want you to build this. In fact, I have an ongoing AI startup challenge that is, look on my Twitter feed, that it's incentivizing people to build with this. All right, so let's get right into building, right? So first of all, step 1, the structure of the app. What do we want our app to look like? So I'm building this for Android, which is one example, but we could easily build this for Node. We could build this for iOS, whatever platform you want. But I felt like Android has the biggest market share in terms of mobile right now. And also, if I'm talking about a personal assistant, I'm probably typing away on my phone. I'm not in a web app, in a chat window. I'm likely on my phone. So I thought Android would be a good way to start. Now, I know that there is Flutter, and Flutter allows you to build, apps for both iOS and Android, but for this video, I want to start off with Android. Maybe I'll do Flutter in the future. Request that in the comments. We'll see. So back to the structure. So Android uses the model view controller architecture. And the activity is considered the controller in that step. So we have several different activities that we'll use in our app. And the way the Android activity lifecycle works is that whenever an activity starts, a bunch of event listeners like onCreate, onStart, onResume are waiting to be fired, right? And then they are fired at certain points in the lifecycle. And our goal is to put the logic of our code into these event listeners. So for example, in onCreate, right when that activity starts, we might want to say, initialize our Firebase object so that once the user logs in, then we're going to authenticate that user and send a request to the server to then store that user's credentials, for example. Or if they click a button, then go to the next activity, right? So that's the Android lifecycle. Now, the way this app could flow, it could get very complicated, right? And apps do get complicated. A lot of these user flows go back and forth and in a circle, and they're not linear. They go in all different directions. And it gets more and more complicated. But to start off, we're going to just work with 3 different user pages for our mobile app. The first one is the login activity. And so just think through this with me for a second. There's not a lot of visuals for this next minute, but just think through this. It's a useful before we get started. So here's how it works. The user will log in. They'll type in their username and their password, right? They'll click log in. What's going to happen is that we're going to take that text and we're going to send it to Firebase. Firebase is the cloud service that acts as a database for us, right? So we're going to store that user ID and password and their auth token in Firebase. Firebase will return back to us a token that says a user has successfully logged in. We'll use that to make sure that the user's session is running throughout the Android activity lifecycle. Now, once a user has logged in, we send that data to Firebase, the button login is clicked, then we'll move on to the next page, which is the payment activity. Inside of the payment activity, we're going to use Plaid's API code to authenticate a user with their bank account. And luckily, Plaid has this amazing tool called Link that shows all of those bank accounts already integrated, and we just have to kind of copy and paste it into our code, and then we can integrate with those services. Now, once a user has logged in with those services, that includes the UI. That UI you saw with those banks, Plaid did that. And so once we have that, we're going to get back a token from Plaid that says, great, this person has authenticated with their bank. We have their transaction data. We have their bank data. We can make purchases with that. We can do whatever with that. The user has given us permission. We'll take that Plaid token. We'll save that to Firebase as well, right? So now we have made 2 requests to Firebase. The first one was to authenticate the user. And the second one was to save that Plaid token so that we now know what this user's bank credentials are, at least a token. And then we send that data to the next activity. And in the next activity, we're going to recall that visualization pie chart. We're going to take that Plaid transaction JSON data. We're going to parse it with some JSON parser. We're going to display it for the user to see as a pie chart because it's got those categories embedded for each of those transactions for the past month, the past 30 days. And then we're going to send that transaction data to Firebase to store that. We're then going to pull 3 tweets. Okay, so we're going to pull 3 different mentions, sets of mentions of both Apple, Google, and say Twitter. You know, all these different stocks, or Apple, Google, Facebook, whatever stock we want to use. And once we have those stocks, we're going to pull, let's say 100 of them each. We're going to perform sentiment analysis on the arrays of tweets. You know, we're going to classify each of them as positive or negative, and we're going to get some polarity score, some overall score of how positive or how negative some set of tweets are between 0 and 100. And then based on that score, we're going to compare the scores and see which is the highest one. And let's say Google is the highest one, right? That has the most sentiment for the day. Based on that, we will then make a request with the Alpaca API to make a purchase of the stock with the highest sentiment. Now, we're going to take 4% of this person's budget and we're going to invest 4% of that. Now, 1% is for us, and we're going to invest in Alpaca's API as well with that 1%. And that's how we make money. We take a 1% cut of a user's monthly budget, and we invest that using our own Alpaca API key that's meant for us and our bank account. It's linked to that. So that's the business model. We take a 1% cut of a user's monthly budget and we invest that. And that's how it works. And lastly, once we've done all of that in the budget activity, we go to the main activity, and inside of that, we perform asynchronous pushing and pulling between the Dialogflow agents that we build in the cloud. Before I get started with coding, one more thing. You might be thinking, well, okay, so every time a user logs in, we are going to then make that investment. Shouldn't we do that at a set interval? Yes. And the way to do that is to use what's called a cloud function on Firebase that happens at some set interval. Now, the word cloud function is actually a wrapper around the concept of what's called a cron job. And this has been around in web development for decades, or not decades, a decade and a half at least. The idea is that some process runs server side at some interval, and it just continues to happen at whatever interval we set. And so we can make that investment server side later on. But for this example, we want to just do this all in a way that we can see all the code in one platform. All right, so let's get started with coding. We have a lot to do. So the first step for us is to perform user authentication with Firebase. So let's get started with that. So to start off, I have this build an AI startup repository that I had from a previous video that we can basically just reuse because it had that Firebase functionality that was built in there. And what we can do is we can just switch it up so that it works for our code in this video. So I've downloaded that from that repository. I'm going to open it up and look at it. So, all right, let's get to this. Let's see what's in here. Where's the main layout? And let's see the design of it. Okay, so this is our first login page. This is for the previous app, but we can change all this, right? We can change the image. We can we can delete the image, whatever we want, just like that. Remove it, whatever. But so that's the activity login, now, right? So let's go to login activity, which is the activity associated with that view that we just saw. Right? We just saw that view. Now, inside of this login activity, we've got a bunch of imports. Okay. And so what we can do, and like I said, in the Android activity lifecycle, a bunch of these event listeners are waiting to be fired. So here's what happens. So when a user sets up a login form, okay, we're going to get that from that text view. They're going to get the password view. And once we have both of those, we're going to say, all right, we have both the email and the password. And now we need to make a request to Firebase. So let me do that. Okay, so right in this progress spinner part, when the user has logged in, I'm going to input the Firebase code for logging in. So I'll go to Google, Firebase login, Android auth. And so I'm doing this from scratch just to give you an idea of how I would build this. Okay, so here is the mauth method. So I'll put that right up here, Firebase mauth. No, not up there, over here. And before I do that, I need to add this dependency in the app build.gradle. There we go. All right, and once we have that, we're going to authenticate via this snippet right here. So we've already initialized this mauth object. We'll get the instance of that. And then I'm going to say, create the user using this. So it's going to take that email password, and then it's going to say, okay, if it's successful, update it, create a Firebase user, and then update the UI. So we'll just paste that right there. So of course it's going to be red, but once we implement our library, it goes away. All right, so that is for Firebase user login. Now, database with Firebase. So let's go to Firebase for a second. And let's get started with Firebase. Now, inside of Firebase, we can create a new app, and inside of that app, I'll say, here's the name of my project, test project, and I accept the rules, create project. All right, great, my new project is ready. Now I will say database. What is my database? Create a database. Enable. And this creates a database for me in Firebase. So I've got my database right here. I've created it. I've got my storage. Any files that I upload will go here. In terms of authentication, I can set up a sign-in method. So right now, email password is disabled, so I just have to enable it. And I'll save that. And great, it's enabled. And I can add users here manually with an email and pass, or I could pass that in via my app. And then it's going to show up here under authentication. Now, cloud functions are really interesting because this is where server-side, those cron jobs I was talking about, this is where they would go. And we build those with JavaScript. But right now, we're going to not do that. We're going to go back to our app. So I did the first part, user authentication with Firebase and database with Firebase. Now for bank authentication with Plaid. So let's go to Plaid. Check out the website. What is Plaid? So Plaid is the easiest way for users to connect their bank accounts to an app. Great. I remember when they were just a very small startup in San Francisco. Good times. They've really grown since then. And so has my buddy Brian's Coinbase thing, which we need to integrate, by the way. And so I wanted to mention this. The bad thing about Plaid is that it's only US bank accounts. And we're not trying to build something just for the US here. We are trying to build something for the entire world. And if we, because if we don't do that, someone else will. So you have to, from the start, as Eric Schmidt, CEO of Google, said, you have to, from the start, build something for as many people as possible, because if you don't, someone else will. So don't try to build something for the luxury market. Try to build something for the middle class, the common person, and not just in one country, but everywhere. So even though Plaid only works with US bank accounts, at least it has a Coinbase integration. So Coinbase then means that you can have, people from different countries who use Bitcoin and cryptocurrency, which is not, only in the US. So that's our gateway to the rest of the world. So if you don't live in the US and you want to use this app for now, you can use Coinbase to do so. But we can definitely improve that, and we can add different payment options. This is just the easiest way to start for this prototype, all right? So once we go in here, we can log in, we can get our API keys. Let's go to their docs, though. Inside of their docs, we can see a bunch of their different SDKs. So it seems pretty easy. They've got this quick start right here for Node, which I tried. It was super easy. But you just download it and then run it, and it's gonna pull a bunch of transaction data very easily into an HTML page. So what I did is, as I said, Plaid link Android. And so that took me to this Android page. So unfortunately, Android is one of their least maintained repositories. It was updated 2 years ago. Luckily, it works. So if we go into app, and then we go into source, main, sample, main activity. So it's all in here. All of that code is in here. Let's look through it. So what happens is we initialize a link to Plaid, right? So this is code that we need right here. We're going to start copying this after I explain it. But the first thing for us to do is for us to create a hash map. And inside of this hash map, we have all of that Plaid, authentication detail, our public key, the name of our app, etc. Then we generate a link based off of that, a URI that will then connect to Plaid, via all of that. So this is just appending all this data to a very long URL. And so there's nothing, specific to Plaid here that we have to download. We're just creating a URL. And so once we've created that URL, we'll say, okay, we're going to create a new web view that will open up a web page, an HTML web page, and show the result of that link when we request that link, right? When we make a post request to it. It will then initialize that, and it will create a client. And so inside of this callback, it'll say, great, if the user has connected, that means if there is a connected response in the JSON, then show the public token, the institution they've connected to, and then show all of that data as a JSON response. And then we'll generate a link based off of that. But the point is that what we want is this public token, right? We want that public token to then save to Firebase. So if we just go over here and copy all of this, so initialize link, we'll copy, paste, copy pasta. And there's also these two helper functions down here, generate link initialization URL and this parse link URL code right here. So we'll paste both of those. In the previous app that I built for this boilerplate repository, we integrated with PayPal. However, in this version of the app, we're going to integrate with Plaid. So in this payments activity, which we already have, we just have to, redesign it. I can remove the PayPal button, replace it with Plaid, whatever. But remember that code that we just copied and pasted, remember, where was that code? That code was in their web app. It was inside of their onCreate. So inside of onCreate, we're going to do the same thing right here, and we'll paste that in just like that. And then we'll import the dependency for it. And we also want to save that data to Firebase, right? So once we have that token, we want to save that data right to the Firebase user database. And we can look in the Firebase SDK and their code examples on ways to do that, right? Saving data. Firebase node database, I'll get an instance of the database, and then I'll save that, right? So even if I have a user object, I can say, okay, so based on this user, right, so from the database, once we have that database, we pull that database object, we can get the user objects, and then we can say, let's set these features of this user to, different, categories, whatever we want. And we can have one called token ID, and then we'll say userref.setValue asynchronously, whatever that new token is. So for our example, that would be the Firebase token. Okay, so that's for bank authentication with Plaid, and that's just going to show up. Like we don't need to do anything for that. And I can show you what that looks like right here inside of payments. Look at this, right? So I'm going to change all this, obviously before the video comes out. But it's got my, payment details here, my authentication details for Plaid, and then it's got all this data right here, which I just copied and pasted from their example. It's a very good example, but it creates that web view for us. We don't have to code any of that. And so once I, compile that, it's going to allow us to then be able to authenticate with Plaid very fast. User, pass, login, and now it shows that payments activity. And so this has nothing on there in terms of UI that we built ourselves. This is really just showing directly from the Plaid website, from their API, it's displaying this web view. So all of this is rendered, on Plaid's end, and then we can select any bank here, whatever, and it's going to make a custom login for that bank, which is awesome, right? Just like that. And then for the test API, we just have to type in user good and then pass good, and that acts as our test credential for Plaid. And it's gonna load itself, just like that. Send credentials, hopefully it authenticates, authenticated, boom, pulls that data just like that. Awesome, so now that we have that bank authentication with Plaid, now we want to perform that data visualization with AnyChart, right? So once we have that data, let's take a look at what that data looks like. So we'll go to AnyChart, Android, and we'll find out how that works. But in the meantime, let me make sure I have that string of transactions. So I'll say link data dot get transactions categories, not just the transactions, but the categories of those transactions, and I'll store those categories in string categories. And once I have that, I'm going to perform that. I'm going to create that pie chart with AnyChart, which will then display for the user. So let me just see, like AnyChart pie chart Android example. Google is our best friend ever. Great, 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 great. So I integrate it with this. So I'll put this in the build.gradle, and then I will, come on, where is it? Pie chart, code snippet. Give me that. Give me. Great, there it is. So we first initialize that pie chart, and then we add those values, and then we say, here's the title, legend, set the chart, and that's going to display that. And they did that in the onCreate method as well, so we can do the same. So here's the pie chart. We had an onClick listener if we'd like, and we'll just set that right here. But instead of whatever fake data they had, we'll use list equals categories, right? And now we need to import the library so it doesn't break. Now, on to step 6, configuring Dialogflow for conversation. If we go to Dialogflow, and I've created, several agents now, so it's been a pretty cool experience working with Dialogflow. So once we go to Dialogflow, you can see that I've created 3 intents here. So one intent is the budget, one intent is the balance, one intent is, how much can this person afford? So all sorts of questions related to can I afford X go under the afford intent. All sorts of balance questions go under the balance intent, and all sorts of budget questions go under the budget intent. And there's the investment intent as well, which tells us the price of our stock data. So in terms of balance, so what happens here is I can create a bunch of training phrases like, what's my balance? How much money do I have? What's in my Bankio, Accountio, whatever variation we want. And what it's going to do is going to learn the type of response based on training off of these responses. So the user doesn't exactly have to say these things for us to be able to trigger the response that we want, but it has to be something related to this. And that's the beauty of Dialogflow. Now, how does it actually know our balance, right? So once we have our balance, we've saved that data to Firebase inside of the user's database. We want to query Firebase to get that data. And how do we do that? Well, we build what's called a webhook. So the idea is that we go to fulfillment. Our web service is going to receive a post request from Dialogflow for some data. So we'll create some webhook. It's going to then enabled, right? Just like this. We're going to create some requests to our Firebase service. And luckily, Google runs both of these things, so it's easy to integrate both. And it's going to say, here's, welcome to my agent. Let's get this data from Firebase, from the Firebase Cloud function, and then we're going to display that. And so what happens is under intent, when we go to balance, we go all the way down, and then we say under fulfillment, we say enable webhook call for this intent. And so that's going to use a webhook. So we'll go back, we'll go to fulfillment, and then we'll say enable it, and then we'll make the webhook. So if we go back to Firebase, we'll go to functions, and then we'll create a webhook that will take data from our user database and then allow our Dialogflow agent to make a post request and retrieve the balance data and all the transaction data and all of that Plaid authenticated data that we pulled from the web once the user signed in. We push it to Firebase, store it in the user database, and then our agent pulls that, as per necessary whenever a user makes a request. So it's stored in the cloud. So we can create several different Firebase functions as necessary. On to step 7. So for TensorFlow for sentiment analysis. So what I did was I found this CNN, text convolutional neural network model right here that was trained on a bunch of movie review data, on some Yelp review data, and the goal was to classify this data as either positive or negative. And we can repurpose that data for tweets because text generally has similar sentiment, whether it's talking about movie reviews or whether it's talking about stock prices, right, or company, brands. And so we can look at this model if we'd like, we can see how it's built, or we can use the pre-trained version and not even have to worry about how the model is built. I have several videos on how convolutional neural networks work. Search CNN Siraj. Also search text CNN Siraj for videos on CNNs applied to textual data. But the idea is always similar. Vectorize input data, pass it through a bunch of differentiable blocks, we get an output, and that's our classification, in the case of classification. So we train this notebook in Colab, and then we save it locally. So I actually have the protobuf file right here, saved model.pb. And then what we do is we integrate TensorFlow Lite into our Android app, and then we take that protobuf file and we drag and drop it somewhere into, say, our assets folder, and then we can reference that very easily. And we'll add it to drawable, wherever, and that's our saved model right there as the protobuf file. So we train it in the cloud, and then we move it to Android to make that inference request. So what we're going to do is we're going to perform sentiment analysis on a bunch of Twitter data, and then we're going to use Alpaca for trading. So what we'll do is we'll say Twitter Android example. There we go. So Twitter has this Twitter kit which we can use to pull a bunch of tweets. So in this example, they're only pulling one tweet, but we can modify it so it can pull several from Twitter. And so under payments, once we've got those transactions, we've displayed that, and then we're going to say before we go to the next class that shows the agent, and it's going to be red for now. We're going to import these dependencies in a second. We'll say get the tweet ID that has the phrase Apple, apples, and then we'll do the same for, say, Google and one other company like Twitter even, or Facebook, whatever. And once we have all three of those, we're going to make this request 3 different times for each of them. Say, 1, 2, 3. And then we'll load the tweets by their name, tweet 2, tweet ID 3, tweet ID 2, and then we're going to get the result. So int result, result 2, result 3, and then we're going to store those results. And so I'll go back and I'll do TensorFlow inference with Android. And what do I need to do here? I need to initialize the TensorFlow inference interface. And then I need to say, here's my model file, here's the label file. See how I'm doing this off of the tutorial? And then I'm going to say, great, so I want to create a function that's going to use that inference to then make a prediction. So I'll go down here, create a separate function, and it's not going to be recognize image, it's going to be recognize tweet. And it's going to return not pixels, it's going to return a string, or a value, or binary value. And I'll take that input, and then I will perform inference on it using that pre-trained model, and then it's going to return a value. It's called result. And so the name of this is called recognize tweet. And I'll go back and I'll say, okay, so for each of these tweets, recognize tweet, and then load tweet success. Here's the result. Result 1 equals result, and then I'll recognize tweet the result, and then I'll say result 1 equals recognize tweet, and I'll do the same for each of them. I'll say result equals result, just like that, and then result 2, result 3, and then at the very end. Now I need to be using promises to make sure that this is happening asynchronously, and when it's all done, then I make the prediction, but I'm just hacking through this fast. And so then we have 3 results, and then see if find greatest of 3 values. See how I'm using Google here? Find greatest of 3 values, Android, quick and dirty, Stack Overflow, max of 3 numbers in Java. It's probably one beautiful one-liner somewhere. In max.math, there we go. Thanks, Java. Max.math, result 1, result 2, result 3, and that's the max value, and I can, save it as a key value pair, so then, once we have the max value, we'll see what the key is for that value. I could instead save it as a hash map, and then I'll go to the Alpaca API example, and I'll make a request using that. So let's go to the documentation for Alpaca, and this is the last step. So in their web API, we use the key, and we use the secret key to get the values. If we go to client SDK, they have one for JavaScript and for Python, nothing for Java, unfortunately, but that's okay. How to code examples has these, and then we go to order examples. And so this makes a request to the v1 orders endpoint. And so they have one for JavaScript, but it looks very simple. We just create an order with that symbol, which we pulled, already. We decided what that was using TensorFlow's inference service, using sentiment analysis. And now we're going to make the trade with that. How many do we want? Well, we'll choose that based on the, whatever budget we've allocated, and we'll create the order. And we'll do this not just once, we'll do it once for the user, and then once for ourselves. And obviously we need to notify the user that we're taking a 1% cut at the beginning, but again, this is a prototype, so we do this twice. So obviously, we cannot paste JavaScript code into our Android app, but if we do Android Alpaca like that, Alpaca, there we go. And it's using React. Great. So markets, main application, and then we integrate that right there to make the request. Or we could just build it ourselves directly using the HTTP API and then using an HTTP library. But once we do that twice, here, and then we make sure that we import these libraries so it stops being read. And when we're done, we have our final solution, and we can then pull that data, display it using any chart, and then chat with our agent. It's made that request. It will perform sentiment analysis on all three of those stocks that we hard-coded, and then it will choose the stock to invest in based on the one with the highest score. That brings us to the last question. How do we improve this app? So in this video, what I did was I made the request directly from the Android client, but ideally this is happening as a cron job or a cloud function in Firebase at a repeated interval that's happening, say, every day or every month. I could give my agent more conversational ability, so not just being able to tell you what your budget is and how much you have left to spend and how your investments are doing and whether or not you can afford something, but also it could tell you, what would be a good investment, and it could, its ability to make automated investments could improve with different technologies like deep reinforcement learning. And we don't just use tweets, we use news sites, things like that. We can also let a user modify their budget accordingly. Right now, what their budget is basically what their budget was based on their spending from last month. But we can create a drop down and allow users to allocate their monthly budget as per necessary, and then update that on the Firebase backend. And lastly, of course, we can design it, better. So, in terms of the user interface. So those are all the parts of this app. The code is going to be in the GitHub description. I encourage you to make pull requests if you want to make this better. I encourage you to build an AI startup. I encourage you to use AI technology to make an impact in other people's lives by building a profitable business. That is the way to solve AI. That is the way to use this technology to make your life better and other people's lives better. I hope you found this video useful, and if you have an AI startup idea, share it in the comment section. We'll all give you feedback on it. Please subscribe for more programming videos, and for now, I've got to fly to Spain, so thanks for watching.